All right, so I apologize I didn't get to this last example in the notes. Some of you wanted to see the solution for it, so I'm going to work it. The only thing that's unique about this one is they define a function and they define it on some random interval. So the first thing we need to do is we need to graph it to make sure it is actually one-to-one on this interval. If it's not one-to-one on that interval, then it doesn't have an inverse. So this is an x squared parabola. I need to vertically shrink it by a factor of 2. Vertically shrink it by a factor of 2. And then I need to move it 1 unit to the left. So basically it's going to start here. Then it's going to go over 1, up a half. Over 2, up 4, which is half is 2. So something like this. Let's just do it as a solid line and then I'll... So we got this portion right here. We have this portion right here. So obviously this is not a one-to-one function. However, if you look on the interval from -4 to -2, it is. So I actually only want this graph on that weird little interval from -2, which was a half, to actually, so 1 squared is a half. It doesn't really matter. It's just an approximate. Well, does it matter? That is the question. Well, let's just plug in a -4 and see what we get. If I plug in a -4 into this function, -4 plus 1 squared over 2, that is -3 squared is 9 over 2, so 9 over 2 is 4.5. So at -4, it's going to be up 4.5. And I'm going to include the left endpoint, and I'm going to exclude the right endpoint. So basically my function is this little portion of the parabola for that interval. Okay. All right, so now let's find the inverse. Oh, no, let's first do the domain and range. I always like to do the domain of P. Domain of P is inclusive -4 to -2 exclusive. It's basically the domain right there. The range of P is exclusive 1/2 to 4.5. Let's keep it as decimals, I guess, to be consistent. It's 0.5 to 4.5. The domain of P inverse and the range of P inverse. And again, there's nothing else you get from this lesson. You should understand that you switch the domains and ranges. So the domain of this becomes the range, and the range of this becomes, or they switch. I'll just say they switch. Oh, I made a mistake. This 4.5 should be inclusive. Exclusive 0.5 to inclusive 4.5. All right, so now let's find the inverse. Switch the x's and y's and solve it for y. Multiply both sides by 2. Square root both sides. When you square root both sides, you got to do a plus or minus. Plus or minus square root of 2x equals y plus 1. So y is equal to plus or minus the square root of 2x minus 1. All right, so this is one of those where we have to determine whether we want the positive or the negative symbol. We can get that from either looking at the range or from looking at it graphically. I think I like doing it graphically because it's kind of hard to see. I want the range values to range from -4 to -2. So I guess, well, if you're looking at the range, I want my ranges to range from -4 to -2. So basically, this is -1. I need this to be negative so that I can get a -4 and a -2. If I take the positive portion of it, I won't get these range values. Another way to do it is to kind of look at it graphically. This is the square root function, which kind of looks like this. The positive would be like that. Then you would horizontally shrink it, and then you would move it down 1. So if the positive one is going to look like that, that is obviously not a reflection about the line y equals x, right? We want the one that is reflected down. So I want the one that starts here and it goes downward like that. And then it's stretched. And then it's shifted. So that's the one I want. And that looks like a reflection along the line y equals x. But here's the trick to this one. I need to make sure I have this function for the right domain values. So I want y equals the negative square root of 2x. But I only want it from a domain value of positive 1. See, here's my domain right here. I only want the domain from 1/2 to 4.5. So I only want that portion of the graph. And now you can see, inclusive 4.5. So now you can see that if you reflect this piece across this line, it looks like it's about right. Okay? So here's my inverse function. P inverse of x is negative square root of 2x minus 1. However, I only want it from 1/2 to inclusive 9/2. Yikes. I'll never put a question like this on the exam. This is a little bit much. However, I can guarantee you that I'm going to give you a question on the exam where you have to be careful about the domain and the ranges and watch out for restrictions and figure out whether you have a plus or minus. There are going to be some problems like that. But that's how you do this one.